Okay, so we are on question 7H4 from the second edition of Statistical Rethinking. So I will read this verbatim here. So recall the marriage, age, and happiness collider bias example from chapter 6. Run the models M6.9 and M6.10 again, which are models that are modeling this data set. And compare these two models using WAIC or PSIS. Which model is going to make better predictions, and which model provides the correct causal inference regarding the relationship between age and happiness? And what we're going to discover is that these two answers will disagree. Okay, so one of the models is going to produce or be predicted to produce better predictions based on WAIC or PSIS, but it will be the model that provides the wrong causal inferences. Okay, so let's kind of wrap our heads back around this particular model. So the data is structured in such a way that we know that the correct DAG is here. Okay, that both happiness and age cause marriage. Okay, that makes marriage a collider between happiness and age. Therefore, we know that if we regressed, if we were trying to find causes of happiness and we regressed on age and marriage, that marriage will act as a collider and therefore make it seem as though age is possibly some cause of happiness, which is the wrong inference. Okay, and we know it's the wrong inference because we made the data to reflect that. Okay, so let's go through and run these two models. Okay, so this code is just copied from the book, and importantly, this MID variable, this indicates whether a person is married or not. Okay, and so this is basically representing marriage in our model. Okay, so we're going to compose our two models. Again, this is just copied from the book. Here's M6.9 and M6.10 here, and they differ on the intercept. Okay, whereas this one has so this notation with the rethinking package means that we have an intercept estimated for each level of the MID variable, which again is either married or unmarried, and that's missing in M6.10. So in other words, M6.9 is conditioning on marital status, whereas M10 is not. Okay, and they also both condition on age. All right. So we're going to run these, and we already know, again, because of how the data is structured, that that M6.10 is the one that will give us the correct causal inference, and M6.9 will give us an incorrect causal inference. Okay, and so again, the way that we will know that is because when we look at the summaries of these two models, M6.9 should give us a non-zero value for BA, right? Which is representing the causal effect of age on happiness. Okay, so we can actually look at these two here. Okay, so let's look at M6.10, the one with the correct causal inference first, and we see that its estimation for BA, again, which is the causal effect of age on happiness, is 0, and that's the correct value in terms of causal inference. But for BA, it's not 0. It's a non-zero value. Okay, and in fact, it's reliably negative. So in other words, it suggests that age causes people to get less happy, reduces happiness. Okay, and that's the wrong causal inference here. So. But now the question is, which of these two models is going to produce the best predictive results, at least as estimated by WAIC or PSIS? Okay, and so to do that, we're going to use the compare function, okay, and we'll look at WAIC as well as PSIS here. And it takes a second for the PSIS to run. Okay, there we go. And we see that M6.9, again, the causally invalid model, takes up all of the weight. It's performing much better in terms of predictive ability than M6.10. Okay, again, this is despite the fact that M6.9 has it makes the incorrect causal inference. Okay, so why is this? Okay, well, the answer is that there really is some kind of association between age and happiness once we condition on marriage. And so in other words, there is information to be gained about happiness when I look at both of these variables, okay? But that information is not conveying the correct causal interpretation of between age and happiness, okay? So it's just information without causal meaning, all right? So when we model without conditioning on marriage, even though it's allowing us to make the correct causal inference, if our goal was prediction, we are depriving ourselves of the information that is contained when we do condition on marriage. Therefore, it's not surprising that the causally invalid model in this case provides better predictive ability than the causally valid model, okay? So there's some lessons to learn about all of this. So number one is that prediction and causal inference are different projects altogether, okay? So we can't mix these two up, okay? And that's really, I guess, the second one here, which is we should not mistake predictive accuracy for causal hypothesis validity, okay? Just because a model is making correct predictions does not mean that that it is based upon a model that is providing correct causal causal interpretations, okay? And because of that, we should not use measures of predictive accuracy, WAIC, PSIS, CV, or cross-validation, to select a model that we hope is providing correct causal inference. Again, if we are only concerned with predictive accuracy, well then these different measures, fine, okay? They're helpful and they're useful. But if we're only concerned with causal inference, well, now these different measures become a little bit less useful in a lot of cases, and maybe even completely misleading. Okay. So I guess that is it for this one.